So I'm going to process the images of LDN1622 from Deep Sky West Observatory. The images, the RGB images plus H-alpha are available for download on their website. So first I'm going to open and plate solve the green channel image. So I'm using image 16 to plate solve the image. And it's going to take a bit, that I shortened here in the video. So after 41 seconds we've got the image plate solved, so that we can correct the star color using their PV data. So now you're going to import the red channel. Because the image is not solved, only the green channel was solved, we are going to use unsolved alignment for each channel. Here we have, let's preview it. This is the red channel. So, okay. Let's continue with the blue channel. Exactly the same. This channel is slightly unaligned, so we are going to correct the alignment and merge the channel. So here it is. Now we are going to correct the colors using PV data for the images that are located on the image. There's not a lot to correct, and we are going to import the luminance or lightness channel. Exactly the same, but here we can correct the luminance and try to get what we want in terms of histogram. Okay. So let's correct level, the background color. So I'm going to start with blue. And the blue is over the green. Now the red, more or less. Okay. So now let's white balance again. So the star colors should be more or less correct. So we are going to merge the H-alpha channel now using a max merge that will translate into the image only the pixels where the H-alpha is greater than the red channel. It says the effect that the images are not affected, the star images are not affected by the red channel merge. Now we are going to use SCNR as a way to convert green pixels to blue. So the image less green, and we are going to use wavelet denoising. And I'm going to proceed to blur the chroma information in the image using 2 pixel radius, selecting chroma only, and protection. This is bilateral blurring, in which only the similar pixels are going to be blurred together, and the threshold that says that only pixels that are below that threshold are going to be blurred. So here it is. Now we are going to execute StarNet. I'm using the version 2 and the NVIDIA in the computer to accelerate. This is real time. So now we have a starless image. So we are going to subtract it from the image to compute stars only image. We paste to the buffer and subtract it. So now we have only the stars here and the background here. Now we are going to copy this background. So first we are going to enhance this background using wavelets. Here it is, and now we are going to copy the image and open it in another window. Now we are going to go to the stars and copy the stars. And add it to the enhanced, wavelet enhanced background image. So now we have an image in which only the background was enhanced using wavelets, but the stars are unchanged. Okay. We are going to use local contrast enhancement now to enhance the contrast globally. And enhance the saturation of the image. Okay, let's save the image. This is the image that was not enhanced after using Starlight plus plus to separate the background from the stars. So here we have the final processed LDN1622 image.